Students, welcome to s.mathguru classes. Now today we solve some particular cases, particular solution of differential equation, second order differential equation with constant coefficient. Now let us consider this problem. Solve in the particular cases d square y dx square plus y equal to 0 when x equal to 0, y equal to 4. When x equal to pi by 2, y equal to 0. Now we have to find the result. What is the solution of the given equation? Now solution is that here given d square y dx square plus y equal to 0, then this can be written as d square plus 1 y equal to 0, where d square means d square dx square. Now auxiliary equation m square plus 1 equal to 0. This implies m square equal to minus 1, m equal to plus minus root over minus 1, then m equal to plus minus I. We get imaginary. Roots are imaginary. Therefore, the solution is y equal to a cos x b sin x. If it is twice I, then twice x we get. A cos 1x means 1I means 1x, that means y equal to a cos x plus b sin x. We consider this is number 1. But here some condition given when x equal to 0, y equal to 4. Since x equal to 0, y equal to 4. So putting this value here, now 1 implies in place of y we putting 4 and a cos 0 b sin 0. This is 4 a into 1 b into 0. That means a equal to we get 4. The value of a we get 4. Next condition, x equal to pi by 2, y equal to 0. Since x equal to pi by 2, y equal to 0. Again 1 implies we putting this value in equation number 1. Y means 0, a cos pi by 2 plus b sin pi by 2. We get this. This implies 0 equal to a into 0 cos pi by 2 0 and sin pi by 2 1. So this implies b equal to 0. So what we get? A equal to we get 4 and b equal to we get 0. Putting these values in equation number 1. Now 1 implies we putting the values of a and b in equation number 1, we get y equal to a cos x plus b sin x. This implies y equal to 4 cos x, and this is the required solution. Very interesting solution and problem also interesting. This is the answer. Final answer y equal to 4 cos x. This is the particular solution. Here constant a, b are absent. By putting the values of a, b we get a solution. This is called particular solution. We consider another problem. D square x dt square plus n square x equal to 0 when t equal to 0, dx dt equal to 0 and x equal to a. These are the condition given. Now we have to find particular solution. Here given d square x dt square plus n square x equal to 0. So this can be written as d²+n² into x equal to 0, where d square means d square dt². Now auxiliary equation, this is m² + n² equal to 0 and m² equal to -n², m equal to plus minus root over -n² and m equal to plus minus ni. This one we get this is the auxiliary equation value, m equal to this. Therefore the solution is, so again we get the roots are imaginary. Therefore the solution is here x equal to a cos nt plus b sin nt. This is the solution. X equal to a cos nt, b sin nt. This is number 1. I get this. Now dx dt, our condition given dx dt, we have to find dx dt. So dx dt, a d dt of cos nt, b d dt of sin nt. So this implies dx dt, this is directly write ddx of cos means minus sin, here n we get, then na sin nt plus bn cos nt. If we differentiate directly without showing the chain rule, we get this one. Since this is number 2 we consider, since t equal to 0, dx dt equal to 0 and x equal to a. We putting the values. First equation number 1 we putting x equal to a. Now 1 implies, putting this condition, 1 implies x equal to a. In place of x we putting a equal to a cos n into 0 b sin n into 0. So a equal to a cos 0 plus b sin 0. So this is a equal to a into 1 plus 0, b into 0, 0. A equal to, we get a. Now 2 implies, putting the value into 2 implies this is 0 minus na sin n into 0 t equal to 0 bn cos n into 0. So this is 0 na, this is sin 0 means 0, bn cos 0 is 1. So this implies 0 equal to bn and n b equal to 0. Therefore what we get? Therefore a equal to a, b equal to 0. Now 1 implies, putting this value in equation number 1, a x equal to a cos nt plus b means 0 sin nt. So this implies x equal to a cos nt, and this is our answer. Answer is a cos nt. A cos nt, this is the answer. This is the required particular solution of the given problem. Next we consider another problem. Show that if L d square theta dt square plus g theta equal to 0 and if theta equal to alpha and d theta dt equal to 0, when t t equal to 0, then theta equal to alpha cos t root over g by L is our problem. So this is our equation. We have to show theta equal to this. Some particular conditions are given. Now solution is that our problem given L d square theta dt square plus g theta equal to 0. d square theta dt square g by L theta equal to 0. d square dt square we write capital D plus g by L, theta is common, this equal to 0, where capital D square means d square dt square. Now auxiliary equation, this is m square plus g by L equal to 0, m square equal to minus g by L, and m equal to plus minus root over minus g by L, and m equal to plus minus I root over g by L. We get this. Therefore, the general solution is theta equal to, this is imaginary and plus minus given, a cos root over g by L t plus b sin root over g by L into t. These are general solution. We consider this is number 1. So actually this is our answer, but some particular condition given here, theta equal to alpha, d theta dt equal to 0, and when t equal to 0, then theta equal to this. So we first differentiate this one with respect to t. Now we differentiate this d theta dt, this will be a d dt cos root over g by Lt plus b d dt sin root over g by Lt, and this will be a, this is minus sin g by Lt into root over g by L, b cos g by Lt into g by L. We get this. If we differentiate directly without showing the chain rule, we get this. d dx of cos means minus sign, and this differentiating we get this, and tt1, and here also d dx of sin means cos, we get this one. So what we get, d theta dt, finally we get minus root over g by L a sin root over g by L t plus root over g by L and b cos root over g by L t. We get this. So this is number 2 we consider. And the condition given theta equal to alpha d theta dt equal to 0. Since theta equal to alpha given, d theta dt equal to 0 given, and t also given 0. Theta equal to alpha, d theta dt 0, and t equal to 0. Now 1 implies, putting the values in equation number 1, in 1 we have theta equal to a cos root over g by L into 0 plus b sine root over g by L into 0. And theta value given alpha. So we putting alpha equal to a into 1 cos 0 1 and b into sine 0 0. So a equal to we get alpha. We get this. And same values we putting 2. Again 2 implies d theta dt is 0 given. 0. And equation number 2, this is minus root over g by L a sine g by L into 0 plus g by L b cos g by L into 0. We get this. And this implies 0 equal to, we can write directly 0 because sine 0 0 0 into something is 0. And this is g by L b, this is 1. Cos 0 is 1. So ultimately we get b equal to 0. If we divide both sides by this, b equal to 0. Therefore, what we get, a equal to alpha, b equal to 0 we get. We putting the values in equation number 1. Now putting the values a and b in equation number 1. Now 1 implies theta equal to a. A means alpha cos root over g by L t plus b. B means 0. 0 sine root over g by L t. We get this. So ultimately this is 0 and we get theta equal to alpha cos t root over g by L. And this is the proof short. This is the complete solution of the given. Very easy solution. To seeing the problem is this is very danger, but this is not danger. Ultimately by systematically solve we get our answer. So dear students, these are very easy, interesting problems and these are important for any engineering courses. It may be civil engineering, it may be mechanical engineering, it may be computer science engineering or electrical, electronics. So these are very important, and BHC major also, major pass course both important. So I hope you are all enjoying with me. If you are all enjoying, then please like this video. If you are new in my channel, then please subscribe my channel and click the bell icon. Thank you.